So I'm now going through question 12 of the AQA June 2022 paper. So it says a geometric sequence has a first term of 1 and a common ratio of a half. Find the sum to infinity of the sequence. So let's have a go at that. So straight from, I don't know what did there, let's try that again. So straight from the formula booklet, the sum to infinity is equal to a over 1 minus r for a geometric sequence. And this is pretty straightforward, it's bung the numbers in. So a is 1 and our common ratio is a half. So it's 1 over 1 minus a half, which is 1 over a half, which would just be 2. So for that one, sum to infinity is 2. That one's not too bad, is it? Then it says, hence or otherwise evaluate. So between 1 and infinity, so you want the sum to infinity of sine 30 to the power of n. So let's think about a geometric sequence here. So think about geometric is we are multiplying by the same thing each time. So sine 30 to the n is just going to look like this. So it would be sine 30 to the power of 1. Then it would be sine 30 squared. And then sine 30 cubed. And you get the picture. I don't need to keep going on, I'm hoping. So what we are multiplying by each time there is sine 30, aren't we? We're multiplying by sine 30. That's not a very good sign, is it? Let's try that again. We're multiplying by sine 30 each time. So that means our common ratio is sine of 30. And then a, well, what happens when n is 1? Well, it's just sine 30. So a and r are both sine 30, and sine 30, if you bung that in on your calculator or you know your exact trig values, that is a half. So sine 30 is a half. So a and r are both a half. So therefore the sum to infinity there will be a half over 1 minus a half. So that would be a half over a half, which would just give me a value of 1. So for that one, the sum to infinity is just 1. So then we have find the smallest positive exact value theta in radians satisfies that equation. So it's a similar concept. We just need to remember that n this time is 0. So let's think about how it's going to affect things. So for our first term, it's going to be cos theta to the power of 0, which is just 1. And then our common ratio, it's the same as before, where we're just timesing by cos theta every time, because it'll be cos theta, or it'll be 1, then cos theta squared, then cos theta cubed. So the common ratio there is just cos theta. So let's put that into our formula for the sum to infinity for a geometric sequence. So that'll be 1 over 1 minus cos theta. And I know that's equal to 2 minus root 2. Okay, so I've now got that. So now I basically just need to rearrange that for cos theta now, don't I? So what I would do here is I'd multiply everything through by 1 minus cos theta, and I'm going to divide by that 2. Actually, no, what I'm going to do is I'm just going to flip it. I'm going to find the reciprocals of everything, which would be the same thing, but it's just a bit of a smoother process, I think, and we can do it in one step. So that'll be 1 over 2 minus root 2. So I've just basically flipped everything. I'm using the reciprocals because I think that's a bit easier. And then if I want to make cos theta the subject, I'd add cos theta across and I'd take away the 1 minus 2 root 2. So if I do all that, that would get me that cos theta, apologies for my S's, looking up for my S's, will be 1 minus 2 root 2. Sorry, 1 minus 1 over 2 minus root 2. So then we're just going to inverse cos that and scroll down. That's not scrolling down. There we go, try again. So then let's just inverse cos that. That gets me theta in radians. That gets me 3 pi over 4, which would be about 135 degrees. And we just need to check that is the smallest value, because we know for cos and trig values, obviously, they are periodic and they repeat and they have multiple values. So if we just picture cos, so cos does this. So that's pi over 2, that's pi, that's 3 pi over 2. And if I make that out of pi over 4, so that would be 2 pi over 4. That would be, whoops, that would be 4 pi over 4. So we've got 3 pi over 4, so we're somewhere here. It is 135 if you turn it into degrees. It's there. So that's the smallest value that we're going to get. The only other value is here, which would be bigger. So that is our solution. Theta would therefore be 3 pi over 4 to make the sum of infinity 2 minus root 2.